Everyone, welcome to another episode of Song Talk Show. We are going to code Wolfram language Mathematica today on mathematics, geometry, plane curves, hyperbola, and I'm going to show you how to create animations in Wolfram language. There are two kinds. One is interactive. That is, for example, you can create a polynomial, a curve, then you can create several sliders. You adjust the sliders and you see the graph change interactively as you move the slider. That's interactive animation, okay? Or interactive graphics. Of course, then you can rotate. You can create a surface, 3D surface or 3D object, rotate it, change parameters in real time and see it change. The other thing is creating an animation. So let me show you an animation. So yesterday we did Unicode math symbols in programming languages. In Emacs, we talked about this guy. So check out yesterday. And so today we back to Wolfram language. In the past 2 weeks, I've done several Wolfram language. So we did parabola, we did this one. See the optical properties, beautiful. But okay, but let me go to today, what we want to do. Okay, so you can see these beautiful 3D surfaces. Okay, we did this one live. This is hyperboloid of one sheet. Okay, this is called hyperboloid of one sheet. Why one sheet? Because there's only one sheet. Because there is also hyperboloid of two sheets. Okay, so this is hyperboloid of one sheet. We did this live on YouTube about 3 years ago. Is that beautiful? You know this. So you can see. Go to your kitchen. In your kitchen cupboard, take out a bunch of spaghetti. Long noodles. You put them in a jar, twirl it a little bit, then you get the spaghetti fall into these chopsticks, and they form a surface. They form a surface that is hyperbola of revolution. So you take a hyperbola. Like this, just a curve, plain curve. You rotate it around the center axis. Then you get that hyperboloid of one sheet. Beautiful. Okay, so you have to see each one of these glorious, beautiful mathematics. Now, as we talked about mathematics, beauty of mathematics, there are two parts. One is just the sheer visual beauty, like this one, hyperboloid of one sheet. So you can see one of the property immediately came out is that this surface is actually made of straight lines. Every point on the surface is a line. So it's a line on the surface. Okay, so this surface is actually made of straight lines, and then it is also a hyperbola of revolution. You rotate it. So there's so many interesting, fascinating, beautiful properties. And this picture, you see, this is in Second Life. Second Life, I lived in Second Life for like 3-4 years. Second Life is another interesting topic. Okay, so you can play chess. You can have these fireworks in Second Life. It's immersive. When you are in Second Life, like you can walk around and turn your head. And then you see this immersive. You get immersive experience. So, but today you got 3D goggles. Okay. So, but anyway, where's that chess? Indoor games. That chess. I wanted to show this one. So, a mouse character is playing chess. So you can play chess in Second Life. You can move those chess pieces. So I had tremendous fun around 2007 to 2011. Basically, I spent like 5 hours a day in Second Life. You can also play all sorts of games, okay? Also, Second Life is an interesting thing. But let's go back. let's go back, because that's not today. We were talking about hyperbola, okay? So hyperbola, so I was saying, oh, by the way, if you roll a dice, a cube, you spin it, that shape, the silhouette formed on the side is a hyperbola. Why? Because obviously, just like this rotation of a bar, so the silhouette of a rotating cube is a hyperboloid, okay, hyperbola, okay. So and this is also intriguing. You can see. Can you play it loop? You see, intriguing. It seems impossible, you see, but it demonstrates how the hyperboloid surface is actually a surface made of a single line called ruled surface, okay? Any surface that can be made by just moving a line, those surfaces are called ruled surfaces, okay? And then hyperbola is, you can see a lot of hyperboloid of one sheet or two sheets in architecture, in planetariums, in towers. This one is Tokyo Tower, spectacular Tokyo. Kyoto, is it Tokyo or Kyoto? Kobe, okay, Kobe or Kobe in Japan, okay? Then you have the gear. So I need to update this gear picture so that it's actually a photo. So this gear allows you to have two axes in a oblique configuration. So you want to, for example, a car transmission system. You see, but with the car transmission, it's orthogonal, but you want it to be able to, if they are not orthogonal, so you got this hyperboloid gear, okay? So if you guys in the mechanical engineering department, any photo of the real hyperboloid gear, show me. I need to update this drawing, because this drawing is not very well made. You can tell this drawing is from the book Penrose Tiles to Trapdoor Ciphers. It's not very good 3D draft, okay? So back in the days, 20 years ago, you don't have computer-aided design system. You don't have computer graphics like that, so you draw it manually. But this one is not well done, because you can kind of see it's not very well done. Okay, so I was saying, now back to previous topic, I was saying in mathematics, there's two kind of beauty. One is the sheer visual beauty, like so far we've talked about, sheer visual beauty. But the other beauty is intrinsic. That's these equations, that takes, so like this is what gets mathematician excited, because when you understand the formula, the curvature, then you see the properties, then it's sheer abstract beauty without any pictures, geometry, okay? So this is hyperboloid of one sheet. Now, so what is a hyperboloid of two sheet? That's like that, okay? So you again rotate hyperbola, but you rotate this time. This time you rotate around the horizontal axis, okay? That's called transverse axis. Then you get this hyperboloid of two sheet, okay? Okay, so anyway, so what we're gonna do today, so is an introduction good? I'm going to start to code, okay? Say hi. If you are here, say hi. I'd love to see your comments. If you are not here, skip around, play at 1.5 speed. So we're gonna do animation, okay? Let me finish the hyperboloid. So hyperboloid of one sheet, hyperboloid of two sheets, one sheet and two sheets, and then we were talking about hyperbola, and we were talking about the beauty of mathematics of two aspects. One is purely visual, the other one is intrinsic, the abstract the group theory, field theory, ring theory, abstract algebra. Those are or topology or complex analysis or analysis. The sheer abstract beauty. Okay, so but what is it we're gonna do today? So you can see this animation. This animation illustrates one of the properties to generate a hyperbola or to draw a hyperbola. In other words, this is a way to construct, that's how they say, construct a hyperbola, okay? So you can, by this mechanical means, create a hyperbola. But, okay, so those are animation I created 30 years ago. Today, we're gonna do this real time. Okay, am I good? Check video, check audio, check. I think I'm good. So say hi, okay? Say hi, say hi. Okay, so let's start to code, okay? Show in browser. So this is today's talk show. And go to Hyperbola. So move this to the top. Hyperbola, okay? Let's go there. Open the page. Show in browser. Okay, now there's a notebook. Go back to here. Notebook. Make a backup, open it. So this is Wolfram Mathematica, Wolfram language. You can download for free. All you have to do is check out my website, okay? Sound Talk Show, Wolfram language tutorial about the author, Wolfram language in-depth download. You can download for free. Okay, so here is my old notebook. So there's one last thing remain to do. So this is 30 years old notebook. All I want to do is just convert these animations, update it, put a code on my website, then basically delete this notebook, okay? So let's begin. Okay, so close this. Show in browser. So we want to go to the section where go down, rectangular hyperbola. Okay, this is x times y equals to 1. Very simple. So this is a hyperbola rotated, 45 degrees, and they are rectangular hyperbola, meaning that they are asymptotes forms orthogonal, forms a cross, okay? So rectangular hyperbola, they're point-wise construction, okay? So this method is derived from the parametric formula for hyperbola secant and tangent x equals to secant t, y equals to tangent t, okay, where AB are radiuses of the concentric circle, okay. If A equals to B, then the curve traced is a rectangular hyperbola, okay. So we can do this. Let me show you another thing. That's GeoGebra, okay. So this is GeoGebra. You can see I constructed, like over 100 of these in the past 20 years. So you can adjust so the way you do this is that it's magnified, okay? So the way you do this, you start with two fixed circles, A and B. So you see A and B, two fixed circles, okay? Then you draw a line. Let's see. Then you draw two lines touching, that's tangent to the circle. So you got the circle A, you draw a vertical line tangent to it, okay? Then you have another circle, you do the same thing. You have a line tangent to it. So you got two lines, okay? Two vertical lines parallel to each other. Then what you do, then you draw a line from the center of the circle, okay, to any point on the circle B, okay? Then, so let's see if we can magnify this. Yes, we can. Okay, so let me just do this clear. Can you guys see? So two circles, A and B, and two vertical lines here and here. Then you draw a ray from the center of the circle Okay, then let's see how it works. So you see, visual mathematics is such that you can just look at this graph and see how this works. So you can see this blue curve is a hyperbola. So, but how is it formed? Let's see. So you draw a ray. Okay, so the ray will intersect these two vertical lines at point A1 and B1. You can see A1 and B1. So so this ray will intersect these two vertical lines at point A1 and B1. Okay. Now take the inner vertical line, draw a circle. You got this green circle. Can you see? You see the, okay, so let's start moving. So take the inner, you draw a circle passing the A1. Okay, you form this curve. This circle. Then you draw another vertical line tangent to the new circle. Okay, then you draw a horizontal line passing the B1. Then the intersection of these two new lines is a point on hyperbola. Okay, there. So you can see as you change this direction of the ray, they trace out different points. So for example, right at here, you got, okay, can you see? You got, you got, so you got this line and this, okay, so you cannot use the pen. You got this circle, you got this vertical green line, then you got this horizontal line. Their cross point is the point on hyperbola. Now, if you change this ray, let's say smaller, let's say same thing, okay? Same thing, exactly the same rule apply. Then you got a point here. You see the point for the hyperbola is the two green lines. Okay, so let's go slowly. Look at the two green lines. Can you guys see it? Okay. We're losing users. Stop the philosophical zombies. I love Wolfram. Okay, so I'm not sure actually you guys can see this because the lines are too thin. Okay, maybe I wasted time. But anyway, okay, let's go back here. So I want to, this code is in my package. Okay, so let's go to the package. So here's a code. Search for hyperbola generator. So there it is. So you can see here is a code, and the code is about 50 lines. Okay, so in fact there's a lot of tabs. Okay, I want to remove that. Okay, show white space. Let me do that. Hold on a second. So replace tab by space. Okay, do it. Okay, we kind of done it. So let's see. Let me just copy it here. Okay, so go back to Wolfram language, open a new one, paste it. So now it might look better here. So let's magnify. So here's the code to generate this animation, and let's make it Shift Control N so that they are formatted typeset. Okay, so you can see the square root there. Okay, so let's look at the code. So I believe that's it. This is an independent code. Okay, yeah. Okay, so this is actual, this part actual calls the function. So let's try that. Copy. So go down here, go down there, paste. Control Shift N to make it typeset. Now go up. Now let's see, where does this begin? Okay, so split, and I want to, hold on a second, copy that, go to the top, clear this symbol. So that's the only symbol we are defining. Okay, so this defines the option for the parameter for this. So hyperbola generator given a radius list, so you need the radius, you need 2 circles. Okay, can you guys see the pictures well? Can you guys see this picture well? Let me know. Is a line too thin to see? Is it visible at all? So anyway, so you need, so this function takes 2 radius, that's the radius of 2 given circles. Then you take a range list. Okay, range, that's 0 to 2 pi. That's how much you want to sweep. Okay, if you omit it, then it's gonna be 0 to 1.4. Okay, that's the default value. Okay, then whatever come after that is just the options, which is number of frames. Okay, now I know how to use this function. The function has a usage documentation, which is here, so we can let's might as well paste it there. Okay, so that's the documentation for this function. Okay, but I already know how to use it. So here is 2 radius 2 and 1, then from 0 to 2.1.25, so that would be about less than half pi. So pi is 3.14 something, half pi is 1.56 something, so 1.25 is a little bit less than half pi. So that, basically 80 degrees something. Okay, so last frame only true. Okay, let's eval the whole thing. Let's just evaluate it. Shift enter. Fantastic. You see, it generates an array. Fantastic. Now there is some minor issue here. So option, unknown option, last frame only. Okay, I think I removed that option. Let's see. Yeah, I removed that option. So delete that. Let's do it again. Okay, so you can see, can you actually see it? Yeah. Okay, so now we want to make this animation. Okay, so let's do that. All you have to do in Wolfram language is to say animate. Okay, add that expression, shift enter. No, so animate is actually, let's see the documentation. Animate expression something something. Okay, so that's not the command we want. This is the animate. Okay, so let me show you this. So you see, so if you have a sign, you want to plot sign x plus a, where x is a variable, and a is a constant, but you want to change a, you see what happens. Then you can plot it, then you can say animate, okay? But what we want here is not this. And also you can do it interactively. So for example, so that's the power of Wolfram language. Let me copy it, so let me show you. Stop. Play, parameter, change parameter A, stop. Play, change parameter B. So you can drag the slider and you can see how a parameter to a function changes the graph. So this is really tremendous, okay? This is tremendous technology. If you are studying mathematics, this is tremendous. So Wolfram language is free, just download it, okay? I recommend it. But that's not what I want. What I want is the list animate, because we already have like one bunch of graphics, okay? So what we do is just list animate, okay? Shift enter. Fantastic. Can you see that? The generation of a hyperbola, okay? The construction of hyperbola. So you can, let's play it backward and forward. Beautiful. So I wrote this like 30 years ago, okay, when I was young, 30 years ago. And the code is just here. The code is, this about 100 lines, okay. This is a body, okay. Okay, what to do next? What to do next? Well, I mean, for me, I just need to update these graphics. So I can export it to this animation. I can export it to an animation. So let's try. Right click, convert to from canvas, get coordinates, make graphics, print, cut graphics, save graphics as, no, I believe there is a animation. I forgot what's the command to create an animation. So hold on a second, let's see. Edit. I forgot what's the command. What, how do you so let's see. Okay, so go back, talk show, today's talk show, Wolfram language tutorial, go down, you see number, boolean, list, expression, atom, head, just like Lisp. Variables, how to declare variables, conditionals, loop and iteration function, pattern matching, data structure, getting advanced, symbol, principles, full form. Then there's graphics programming. That's what we want. There it is at the bottom, animation, okay? Okay, so this section is still work in progress. So here is how you do animation. But my question now is, how do you save? Oh, I forgot. So we already got the animation here. We just want to save it. What is a save? Export something, okay. Get coordinate, make standard size, save graphics as. Let's try that again. PDF, HTML, BMP, EPS, that's PostScript, GIF. Okay, I don't want a GIF. I want a movie format, okay. Wait, how? I have notes somewhere, but I forgot what is the okay. let's finish that, and that's it for today. Okay, I forgot what is the command to export to animation. Let's see the documentation. So this anime, okay, that's not what we care. Okay, manipulate. So this bunch of animations and moon phase. So let's shrink this a little bit, resize. I forgot. Let's say export animation. Let's see, search importing, exporting video. Okay, let's try that. Okay, so you can import MP4 video. You can import audio part of it. You can import MP4 as a list of images. You can import MP4 as a duration. Oh, you can like import just the how long is the video. Export, okay, so export, there it is, export. So export, there it is. Now I remember I have a notes about, you see, so hold on a second, let me show you. Okay, let's go back here and let's save this to a variable. So x animation x movie equals to, okay, and don't produce output, shift enter, done. Now all you have to do is just say this animate x movie. Okay, there you have the movie. Then what we want to do now is to say export. Okay, export, then so export of that. Okay, so but first of all you need a name. So what is the name? You want it to be X test movie. Okay, dot let's try GIF first. Okay, then this part will be that. Okay, do it. Let's see how long. It shouldn't be take too long. It's okay. Thank you, Thiago. Fantastic. Thiago, are you in Brazil? I forgot. Are you the guys in Brazil? It's done. Fantastic, guys. So let's go to desktop. I believe it's saved in desktop. No, wait. What is this? Test movie. Where is it saved? Documents, okay. There it is. There it is, okay. Now let's open the GIF. Let's see. There it is. Fantastic. Can you guys see it? Beautiful. Now the file size is 800 kilobytes, okay. Now let's try it again, but now instead of GIF is no good, okay. Let's try MP4. Shift enter. Processing expression for video export. Remaining time 20 seconds, 19 seconds, 16 seconds. Beautiful. Wolfram language. That's why I'm telling you guys, Wolfram language is a magnitude beyond anything you've seen, Haskell or whatever. Closure, Haskell, Rust. Okay, it's done. Refresh. There it is. MP4, 90 kilobytes. Open it. Fantastic. This is even more beautiful. Okay, so can you like what? Yeah. Oh, fucking stupid. This VCL player, stupid, idiotic from the open source Linux. Like every time you like after it plays, it becomes this thing. You can't just play click play again. You see, the Linux idiots and Unix idiots, they are incapable of creating any software that involves a user interface. Let me explain this one, okay? Because this is extreme idiotic to the extreme degree. Typical, very, very typical example of the Unix, Linux situation, including the C idiots, okay? So you see, you got a movie, right? So if you play this in, let's say, in Microsoft, any player on the Mac or, let's say, Windows Media Player, okay? I don't like Windows Media Player, but, actually, I don't, I don't want to. Yeah, I don't even want to try. But anyway, if you open in the VCL player, which is open source Linux, so you get that. But once, wait, click, finish, like once it finishes, it becomes this index page. Which video player does that? What incredible idiocy. This brainless, look, you play a video, when it finishes, okay, for some reason it stops, but continue, oh, it's the end. Like extremely idiotic. This is like the user interface aspect of the Unix and Linux thing. Okay, but anyway, our video are successful, so let's just copy it. Let's copy both of them. You can also try to export .mov. Let's try. Okay, actually I want to see, I did this before. I want to see which one produces the maximum quality with the least file size. So now it's a .movie file. Okay, done. So now refresh. Now we got 3 files. So the .mov is actually, okay, 300 megabyte. MP4 is the best, okay? But anyway, copy the file path, close, go to the Hyperbola page, open, then go to the construction, point-wise construction. Let's just paste them there, okay? Now make it into a embedded GIF. So it's so fast you don't know what's going on. So, but let's move the file into the current directory, okay? So if you show it in browser now, go down. You see, there we have it. So the first one is GIF, okay? Now the second one is .move. It won't play in the browser, so that sucks, doesn't play in Firefox. The third one is MP4. Click play. Beautiful. Okay. Now let's show this page in in a Chrome browser. Okay. So, but before we do that, let's change the file path into the current directory, because this is my website. You don't want it to link to your document directory. So I have an easy command. Press. Okay, let's just say I. Okay, done. So it's automatic. Press I. Okay, so press I. So they moved into the current directory there. So you see, there. Okay, so the command I just called is XAR HTML move source file path. That's part of my own command. You can get it if you want to, pay me $30, $40. Go to XAR Emacs website, search for XAR Emacs HTML mod. Pay me, PayPal me, I'll send it to you. So okay, so we got, so wait, what are we doing? So you got these files. Now show this file in a Chrome browser. You see right now here it's Firefox, but let's close that. VLC idiotic. Let's go to this is a Brave browser. Okay, Brave browser. So press. There it is in Brave browser. Now go down. There it is, GIF. Okay, this is the move file .mov. It doesn't play. Okay, so okay, movie file is not good. MP3 is good. Play. That's it for today. Thank you guys for watching. Okay, if you enjoy my stuff, just pay me. Okay, just go to PayPal, go to xardi.info, and xardi.info. The site is called XAR Code. Then scroll all the way down. You got all these tutorials for programming languages all the way down. Just PayPal me. Okay, PayPal, Amazon gift card, $100. Bye guys. My VLC player on Linux is normal. I think it's just Windows. Okay, yeah, maybe you are right. But VLC, I've been using VLC on Linux. Lots of problems. Bye guys. So we talked for 50 minutes. That's good.